Hi, good afternoon everybody. I'm Charu from Qure and I am here with Dr. MJ Negahdar today. He is an assistant professor at the Department of Diagnostic Radiology at the University of Louisville. He manages an imaging research facility at the School of Medicine at Louisville. He's also a research faculty member of Center of AI Sciences at University of Louisville. So without further delay, I'll hand it over to MJ.
Thank you, Qure, for the opportunity to present the project here. So I'm a member of Department of Radiology at the University of Louisville and faculty member at the Center for the AI at Department of Radiology. And this project actually happened as a part of the Center of the AI in the Department of Radiology. At the Center of the AI at the University of Louisville, we have developed some expertise, to some new AI project, including testing and evaluating the AI protocol and program. So this project was one of the projects we have done over there. In this project, actually, we try to evaluate, the efficiency of the Qure AI algorithm in the chest X-ray at the Department of Radiology in the ER room. So we evaluated around 111 patients who came to the ERs at the University of Louisville. So in the last week of the September. So all of the patients that we see here, it's for the last week of the September. So we compare and contrast the result of the Qure output with the radiologist note. So we compare and contrast to see whether they are in the concordance or there is a disagreement, and what are the specificity and sensitivity of the algorithm. And at the end, we try to find out whether we could save the time at the ER, so compared to the radiologist read the notes. Next, please. Next, please. So this table actually shows the turnaround time for the images to be read by the radiologist. The majority of the patients get the results in less than 2 hours. So 88% of the results are in just less than 2 hours, and 95% almost receive the results in around 4 hours. So the next one shows the histogram. So if you see that the most reports just gonna be out in just less than 2 hours. Next, please. So this table shows how we compared and the results of the radiologists against the AI software. The rows shows actually the results from the radiologist note, normal versus abnormal, and the column shows the results that we receive from the AI software. So next, please. Hopefully everything just falls into the green area, so they are in just concordance and agreement to each other. So if the radiologist says that normal, the AI software says the normal too, and vice versa. Both of them says they are just abnormal. So the main thank you. So this table actually shows the sensitivity and specificity of the algorithm. As you can see, that we could reach the almost 95% sensitivity to abnormal cases. So only 2 cases were missed by the software. So, and when we reach to that point, we just try to investigate more to see why the software actually missed those 2 cases. So next, please. So out of those 2 cases, next, please again. One more. So in those 2 cases, actually software missed that, and actually software says that normal, but radiologist says that the case is abnormal. One of them was the clavicle, fracture. So this is one of the, actually issues that, the Qure is not looking for. So in the current version that we have, clavicle fracture is not part of that. So if actually even we exclude this, the sensitivity of the algorithm can raise to the 98%, which is a really great, number. The other cases was, mild atelectasis. So that's the one actually missed by the software and just picked by the radiologist. Next, please. So about the turnaround time, we try to see how much time we spend for each, patient in the ER setup in the University of Louisville. So for this, ER room, actually on average, each patient was over there for 58 minutes. This 58 minutes is the time in between when the image acquired until the dictation time for the radiologist to sign the report. So, but for each group, for the true positive, false positive, true negative, and false negative, these timings are even different. So actually, if you look at that, the cases that were normal actually was diagnosed normal by the radiologist and by the software were actually longer time. It's around 69 minutes. That's the time actually we can save if we use the software. So somehow we can just prioritize the patient and just discharge in normal cases faster. So each patient, normal cases, we save 69 minutes per patient. So actually, if I extrapolate that to all the patients, so on average, it's going to be 29 minutes per patient. So considering we have 58 minutes per patient, on average, saving 29 minutes, it's almost makes the ER time make it to the half. And if I just want to see just correlated to the dollar value of that, could you go to the next, please? So the estimated, the dollar value is that just 69 minutes for 47 patients is almost 54 hours saving in the time. And this is only for 1 week. So we just for 1 week of our ER room. So in just a month, it's gonna be around more than 200 hours of the time saving. And just assuming that's almost the dollar value for the ER is around 1,200. So you can just do the math to see how much it's going to save us the time for the valuable of the ER, and how we can prioritize the patient really actually need the radiologist to read their images faster. Thank you. That's it. Thank you for your attention.